We'll proceed in vector, algebra, and calculus. Vector, algebra, and calculus, and we are in phase of calculating the work done, that is force vector dot product with the displacement vector. So this much we have seen. This much very clearly we have seen, that if someone has force vector, if someone has force vector and he multiplies the force vector with the displacement vector, then he can calculate, someone can calculate the work done. Okay, if that is the situation, then what is the why we are in the calculus class? Means if someone can calculate, if someone can calculate the force into force vector dot displacement vector, then he gets the work done. Then what is the problem? Consider there is a force vector called I plus j. Okay, so there is a force vector called I plus j. Now, if this is x-axis, this is y-axis, then this is origin. Okay, this is I plus j is the force vector, and this x-axis is the displacement. We keep on talking about the displacement vector. This x-axis is displacement vector. Okay, okay, so x-axis. Okay, so x-axis being the okay, so x-axis being the displacement vector. Okay, oh, okay, so okay, so x-axis being the displacement vector. Okay, so I really have x-axis and y-axis. X-axis, x-axis and y-axis. Now this is x-axis. This is y-axis. Okay, so this is x-axis, this is y-axis. Now, if that is the case, then this is force vector. The force vector equation is I plus j. Force vector equation is I plus j, and this is x-axis. If this is x-axis, because of this force, we have taken example, a car is moving along x-axis. A car is moving along x-axis, and in that sense, if car is moving along x-axis, from 0 to x car is moving. 0 to x car is moving. How much energy it is getting because of this force? There is a wind force that is along I plus j. If this is the wind force along I plus j, then because of this I plus j, how much is car is moving 0 to x, car is receiving energy from the fuel. Okay, if car mass is m, whatever it, car mass is m, whatever it. If car is moving from here to here, here to here, and then the energy it generates, if something is moving from one location to another location, the energy it generates is k. That energy certainly it is not coming because of the fuel only, because wind is flowing in this direction. Because of wind also the car is getting energy. How much it is getting? F cos theta into x. That much is the energy it is receiving from the wind. Rest of the energy it is receiving from the fuel. Okay, it makes sense. Means if there is no wind, Then from here to 0 to x, if car is moving, full energy it is receiving from the fuel, and that is something that is more. But if wind is there, certainly it is receiving energy from the wind. Or on the in the ocean, someone can think about a boat with that kind of I don't remember the word, that cloth, and with that people make it, and it helps the kind of flow of the wind. The ship is flowing, ship is flowing or floating on the water because of the air by some engineering. Now, if ship is going x distance, and then in wind is exactly in the direction of movement, then wind force multiplied by the distance, that much energy the ship or boat is receiving from the wind. If there is no engine in the wind at all, if there is no engine in the boat at all, then whatever distance it is covering multiplied by the force of the multiplied by the force vector that is created by the air. Air will have acceleration and mass of the boat, that will be actual force, and then displacement, that is the energy. Okay, force divided by area, force equal to mass into acceleration, force divided by area is called pressure. If I have two forces that are equal in amount, but if I place that force into very small area, then pressure will be high. That's how, where car kind of car repairing shop, or a kind of what I can say, like people give their car for repair or cleaning, washing, whatever it is. Generally, car wash, wherever car wash happens, they lift the car. Okay, the car, someone would see there will be a iron pillar kind of thing on top of it. Car will be lifted. It is generated in a way that force is created and it is applied into very narrow region that creates immense pressure, and car gets lifted. Same force is applied in a big area, then pressure will start decreasing. Okay, that is the scenario. Force by area is pressure. Force into displacement is energy, work done. Energy by time. This much energy is generated in what amount of time, or this much energy is dissipated in what amount of time, that is called power. So, high energy, less time, more power. High force, less area is more pressure. Okay, so this is the science anyway. Now idea is that if I have a force that is I plus j and car is moving like this, then how much is the work done? If car is moving 0 to x, what is the work done by the air? That is I plus j cos theta, I plus j vector. So magnitude of I plus j into cos theta, and then magnitude of this vector. This vector x-axis vector is I vector. The x-axis vector is I vector, that is unit vector. If I say 0 to x, then I can say it is xi vector. So I dot j, that is the air vector, dot product with the xi. That is the work done. That will come as x. That will come as x. Or the here magnitude is x, xi magnitude is x, and magnitude is square root of 2 I plus j, square root of 2, and magnitude of this cos theta, that is the also can be measurable. In that case, again it will come as x only. So if I have a vector and I want that I have a force vector and I want the force vector work done moving an item 0 to x on x axis, then that is dot product of these two. What about this force vector is there and moving an this is x axis, moving an item along new vector like this. Hop, 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 hop. Makes sense, right? Consider this vector is I plus 2j, I plus 2j, and path along which car is moving is this direction. That is I plus j. In along the I plus j car is moving and wind is I plus 2j. Now car is moving in the sense it is going from here origin to a distance here for which x component is x. So for x component 0 to x that is hitting here, okay, in that case, what is the work done by the force air on this car? Now air direction, wind direction, force direction is I plus 2j, whereas car direction is I plus j, I plus 2j, I plus j. Okay, if I need to do dot product, whatever it is, dot product, then for if I do dot product, it becomes 1 into 2, 3. 3 is the work done when the vector displacement vector along with car is moving I plus j whose x component is 1. If x component is 0 to x, then I have to multiply it by x. That is 3 into x. Or I can say that the air vector, wind vector is I plus 2j, and this vector, the car vector is, if I multiply, the way I multiply, original was I vector. Car was moving along I vector. 0 to x, I made it xi. Their car is I plus j, I can make it xi plus 1 xj. Now dot product with I plus 2j dot xi plus xj, that will come as 3x again. If no one, if people are not satisfied, then someone can calculate the angle between it, and then magnitude of the air vector, wind vector, and displacement vector, multiply it into cos theta. It will come as 3 only. Someone can, I believe, try. Or better example can be wind and the car are in same direction. That is I plus j, that also here xi plus xj. Then the wind magnitude is the square root of 2. Displacement magnitude is x into a square root of 2. Okay, square root of 2 into x into a square root of 2. I'm sorry, if they are in same direction, x, that is square root of 2, x into square root of 2, cos theta, theta is 0 if they are in same direction, that is 1. So that will come as 2x, or someone can do dot product I plus j dot xi plus xj, that will come as 2x only. So this is called force dot product in the sense that I have two vector, force vector and displacement vector, and if I want work done, simply go with the dot product and you get the work done. What is the problem here? Problem is that both vector must be numeric vector or static vector or both vector must not be algebraic vector. The wind vector is I plus j, that is constant, and direction vector is I vector. Direction vector is I vector. I multiplied it by x because I want for x distance. There, if direction vector is I plus j, I multiplied with the x because 0 to x along the x-axis, I want the displacement. Okay, all right. What about the force field is vector field? It is algebraic. What do you mean by algebraic? I have demonstrated it algebraic. Consider force vector is xi plus yj. Force vector is not I plus j. Force vector is not I plus 2j. Force vector is not I plus j. Force vector is not I plus 2j. Force vector is xi plus yj. How force vector would look? Xi plus yj. At the origin there is no force. At x equal to 2, this is x-axis. As x equal to 2 and y equal to 0, force vector is like this. When point is 1 comma 1, force vector is like this. On the y-axis force vector is like this because x is 0. I'm sorry, force vector is like this. X is 0 and y is something. What about x minus yj? Here x minus yj. Here force vector will be like this. Here xi minus yj. If point is 1 comma 1, I minus j. I minus j, then for I minus j, force vector will be like this. Okay, this direction. Here, this direction. At this point, in this direction. At this point, minus j. towards the origin. Everywhere the force is changing. It is algebraic now. It is not, it is algebraic now. It is not numeric. In that sense, calculate the work done for the car that is moving 0 to x on the x-axis. The car vector is xi, and the force vector is xi plus yj. Okay, now please watch previous video or previous two videos. Now if I want to do multiplication of two items when one is independent and one is dependent, then we cannot do direct multiplication. That is the problem. If we do direct multiplication, it is error prone. So we go by calculating the multiplication by calculating the area. When we calculate the multiplication or addition by calculating the area of a graph where one is independent and one is dependent, that is called integral calculus. So if I say the vector field for the force is xi plus yj, and then it is xi, both where now we have this force field, we have x, and here the displacement field we have x. Displacement field is along x-axis, that is independent component, and force field which has x, that is dependent component. If I do multiplication like this, then better to go with the integral calculus. Now what we can do is, in the independent component, as per the integral calculus is concerned, we place d out there. Direct multiplication we avoid. So it is xi plus yj dot dxi. If like that, then yj gone. Now it is x dx, x dx, x square by 2 from 0 to x square by 2 is the work done, where x is variable. So what we are seeing in the calculus fundamental is, calculus fundamental says that if you are calculating work done when the force vector is algebraic vector, then it is not straightforward. If it is a constant vector, numeric vector, static vector, then it is all right. Otherwise, there is problem, and you have to go through integral calculus. This is what we saw very nicely. Now, what is the problem here? Problem is okay. Let's calculate for the other side. Let's calculate wind is in I plus 2j. Wind is I plus 2j, and car is moving in direction I plus j. Then car is moving from 0 to x along the x-axis. That much distance it is traveling. In that sense, what is the work done? Then I plus 2j is the force, dot d dot d of the vector along which the car is moving. So vector along which car is moving is I plus j. I multiply by x. I multiply by x because we want for x distance. D of xi plus xj. Here I plus 2j. Okay. If that is the case, then it becomes dx plus 2 dx, 3 dx, x square by dx. Integration of dx is x. Integration of dx is x. Now it is 3x. Simple, right? It does not. It actually does not need any calculus also, because one is constant. I plus 2j dot with xi plus xj will become 3x only. Calculus is not required, but calculus is required. Calculus is required when it is force is xi plus yj. Now xi plus yj d dxi plus xj, that is the displacement vector, because if it was on x-axis, if I vector is the representation of x-axis, then 0 to x I made it xi. Similarly, it is xi plus xj. Now xi plus yj is the force vector, displacement vector is xi plus xj. So xi plus yj dot d of xi plus xj. Okay, integration 0 to x. Now it becomes x dx plus y dx. Okay, what is y? What is y? What is the line equation for the vector I plus j? That is y equal to x. Someone has to find y equal to x is the line equation for the, because if I say y x, these are algebra dependent and independent. We are trying to calculate the dot product along the displacement vector. So displacement vector line equation is y equal to x. Now we can substitute silently y as x. Now we want x dx plus x dx. That is nothing but 2x dx. 2 outside x square by 2. 2 gone, x square. 0 to x distance. X square is the work done, where x is variable. Someone can change it. If x is 0 to 2, 0, x is 2, then 0 to 2. 4 is the work done. Makes sense, right? Amazing, mind blowing. Okay, we will proceed on it. So that is the scenario. Now bigger scenario is arising. What about, now we calculated along a displacement vector, right? And displacement vector is a straight line. If displacement vector is a straight line, then quickly we can find it. Make sense? Now consider that displacement vector, displacement is happening along a curve, not along a straight line. If a displacement is happening along the x-axis, I took an xi. If displacement vector is happening I plus j, I took xi plus xj multiplied by x. If displacement is happening along a curve, where force, if displacement is happening along a curve, no, now this is the wind. This is the wind. Consider wind is xi plus yj. So wind along x-axis it is like this, like this, like this. It is changing. Okay, xi plus yj is the wind. Now, if this is the center of this, if the circle is centered at the origin, then wind xi plus yj, if I say wind is, then wind is like this. It is like radius. Okay. If that is the situation, then if car is moving along a circular direction, circular direction, what is the work done by the wind on the car? Very simple, right? If car is at any point x comma y, at that point you have to calculate the curve vector, line vector, because we are going through line. If work done, we need to calculate along a line. Then we calculate the vector equation of the line and then do dot product. If force vector is xi plus yj, xi plus yj, consider any point on the circle that is xi plus yj, xi plus yj, then what is the, if this is the point called, sorry, this is the point comma x comma y, there is a point of the circle, because everywhere if I take the line vector, if consider this line vector here, it line vector here, what we see, it is I, it is 2i minus j, 2i minus j, and vector and force vector is x plus yj, and the line vector at this moment is 2i minus j, 2i minus j. What is the work done at this moment? This is algebraic calculus. Then force dot displacement vector. The force is xi plus yj dot d 2i minus j, 2xi minus xj. Okay, now 2i minus j, if that is the vector, what would be the line equation for it? There, for y, we will replace in x and settle it down and then calculate the integration. And at that moment, that is the work done. No need to calculate the limit. Okay, but problem here is, if I, any moment if I take a line vector, that is a numeric vector. But everywhere line vector is changing. The line is a circular. Line vector is tangential at that point and it is changing, not circular. Any curve if I take, looks like any curve I take, any, if it is a sinusoidal curve, and along the sinusoidal curve, if it is a sinusoidal curve, Okay, if it is a sinusoidal curve of, if it is a sinusoidal curve, okay, one side is like this and it is actually sinusoidal. So if it is a sinusoidal curve, everywhere the curve vector is tangent to it. So okay, if it is a curve, then it is tangent to it. Whatever straight line, again tangent to it. If I'm trying to find the displacement along a line, then the vector representation of that line is tangent to it, that is parallel to it. Or if it is a curved line, then tangent to it. Everywhere it is tangent to it. If that is the case, if we are taking a circle, if that is the case, then if I am taking a circle, then every moment I have to calculate the tangent vector. And that tangent vector multiplied by the force vector is the work done at that moment. Okay. But what is the net movement? Net movement I want if this is centered at the origin. And if this is x-axis, then from 0 to any x that will hit here. 0 will hit here, 0, here 0 will hit here, 0 to x along x-axis, it will hit here. Whatever the length we are seeing from here to here, for that length, if car is moving from here to here, if x is 0 to a, x is a, that is radius, then car will move completely from here to here. If x is minus a to a, then car will move from here to here. This much is the displacement. Then what is the work done by the force? That is the wind, that is xi plus yj. That is under question mark. Okay, what we have seen till now? We have seen that if I have a static vector, that is the displacement vector, multiply it by x and do dx, d of the displacement vector, where displacement vector is multiplied with the x, dot product with the force vector, and integrate 0 to x, you get the net work done. In that sense, what is the, then I consider the xi plus xj. If I say xi plus xj, what is xi plus xj? What is xi? If this is x-axis, along x-axis car is moving and there is a force vector dot dxi. This is what we are doing. Integration from 0 to x. Actually, it is force vector dot xi vector. But we place d integration sign there because force vector is coming as algebraic vector. In that sense, we cannot directly multiply force vector dot dxi vector. But if it is a straight line, what we are doing xi vector. Okay, what we are trying to do is xi vector means I can take any point x on the x-axis. What is the position vector for it? I take any point on the x-axis, that is x comma 0. Y is 0 on the x-axis. That is xi plus 0y. We are taking position vector. We are taking position vector. So force vector dot d position vector. This is what we are doing. If the displacement vector is I plus j, then we are doing d of xi plus xj. Xi plus xj, if this is I plus j, it is passing through a point called 1 comma 1. From origin 1 comma 1. 1 comma 1. This is passing through a point called 1 comma 1. If I say it is passing through a point that is x comma y, then y is x only because they are same. Then it is passing through a point called x comma x. Then position vector is xi plus xj. Now we are changing little bit. Now we are saying f vector dot d position vector. D position vector is the net work done. If that is the case, then if I take any point P on the circle x comma y, and that is the position vector, then if I do d of the position vector, then that is the tangent vector. Because differentiation of position vector is the tangent vector at the curve. But we will prove it many ways. We are going little bit up. What we did, if we are trying to calculate the work done along the x-axis, then instead of I vector, I took xi vector. If we are trying to calculate the work done along the I plus j vector, we multiplied by xi plus xj. Xi plus xj is same as xi plus yj, where y equal to x. Means this is passing through a point called x comma x. Indeed, it is passing through a point called x comma x. If I take any point on the line I plus j vector, any point, that point is x comma y equal to x, because the line equation is y equal to x for this vector. Okay, this proves that if we are trying to calculate work done, that is force dot dp vector, d position vector. If that is true, then position vector here is xi plus yj only. If I take any point. Now work done along this path is force vector, that is xi plus yj. This is what we have taken. Dot d of xi plus yj, integration over 0 to x. This is the work done moving. The car is moving in a circular fashion where the path is centered at the origin. Okay, I can think about xy is actually xy on the road. X-axis, y-axis, z-axis, that is sky. And car is rotating in a round circle where wind is flowing in a direction x plus y. No need to think about z-axis. Okay, it is all right now. Now car will really, if it moves in a circular, how car will move in a circle? Okay, the way we proved it, take a not nut, bolt, round shape, and place it inside this curve. If you apply wind, then it will try to move along the wind. If wind is in this direction, the bolt will move in this direction. But since it is confined inside the circle, it will start rotating in the circle only. Think in that fashion. Car is rotating in the circle due to some confinement. Okay, due to some constraint. In that way, what is the work done from 0 to x? Car is moving from here to any x. Then it is xi plus yj dot dxi plus yj, because that is the position vector. We are taking position vector inside the d. This is what we are seeing. If that is the case, then along the, if I take circle, what is the line equation? Y x square plus y square equal to a square. Y equal to square root of a square minus x square. Okay, if that is the case, then what is d of xi plus yj? That is x, d of xi is I. d of xi, d of xi plus yj. This is what we are taking. Okay, all right. d of xi plus y, that will become dxi. Sorry, this will become dxi plus dyj, and here xi plus yj, it becomes x dx plus y dy plus y dy. What is y? Y equal to square root of a square minus x square, that is the circle. What is y dy? That is square root of a square minus x square, square root of a square minus x square into dy, d of square root of a square minus x square. What is d of a square minus square root of a square minus x square? Minus x divided by square root of a square minus x square. So net it is coming at x dx plus square root of a square minus x square into minus x by square root of a square, square root of a square minus x square dx. Okay, I believe it's all right. If that is the case, then it becomes square root of a square minus x square gone, and minus x dx. Net integration is x dx minus x dx. I believe it's all right. X dx minus x dx. Okay, if that is the case, it resolves into 0. This proves that if car is moving in a circular direction, and when wind is xi plus yj, certainly wind is not doing any work in the car movement. If car is really moving in a circular direction where wind is xi plus yj, car is moving because of its internal fuel only. Wind is not doing. How come it's not possible? It's not possible because wind is radial. Wind xi plus yj, wind is radial. and car is moving exactly perpendicular to the rail. Every moment tangent is perpendicular to this. So work done along the perpendicular to the force is zero. So in that sense, everywhere the force is perpendicular to displacement and work is not done by the wind. Amazing, mind blowing. What about wind is xi plus xj? Xi plus xj means wind is always in this direction, xi plus xj. If I take xi plus xj, xi plus xj, and we are in x direction, then wind, then at this moment we are on x-axis. Then we are on x-axis. Then point is 2 comma 0. Then vector force wind vector is 2i plus 2j. Here also it will be like this. Everywhere it is in same direction. What would be the work done? Then it is x dx plus x dy. That is x into minus x by square root of a square minus x square dx minus x square. Here minus x square. Here it is x dx and here minus x square by square root of a square minus x square dx or something like that, which is not zero. In that sense, either there is if full net is coming as a negative, means the wind is opposing the car movement or it is supporting the car movement. Okay, so we will proceed on this, that how what actually it is, and then we will prove that how come it is d of the position vector. We just with the assumption we said force dot d of position vector is the work done, how it will be, but it is mind blowing, right? It is amazing. Anyway, please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We will see more on it very thrilling.